your students will be among the very few that truly understand the saying, "That's the way the ball bounces," after doing this investigation using the new wireless force platform. Every physics student knows a bouncing ball will reach a lower height than the previous bounce. By analyzing data from the wireless force platform, they can develop and test a model that predicts the height of future bounces. The Investigating a Bouncing Ball lab requires students to combine their knowledge of kinematics and impulse and momentum to determine the bounce heights. They look for patterns that will allow them to predict the heights for any number of bounces using the concept of coefficient of restitution. Students first explore the forces from one bounce of a racquetball and compare the maximum force to the weight of the ball, and then compare the maximum force and impulse to a piece of clay having the same mass dropped from the same height. So I have a graph display of normal force versus time in Pasco Capstone software. This also would work in SparkView. And I've set the data rate pretty high. It bounces a short interval event to 1 kilohertz. And I'll just eyeball the height. And so right away are some surprising things for them to investigate. The maximum force is many times greater than the weight of the ball. And then why is the clay, which has the same mass, dropped from the same height, have such a smaller maximum force? And what about the impulse? So a lot to investigate there. Students then let the ball bounce multiple times from a lower height. Students find the height of a bounce using the hang time and free fall kinematics and compare it to the height predicted by the initial velocity and the impulse. So you can see the hang time in between each bounce from when the force first drops below zero here to when it first goes above zero here. So that would be the time the ball's in the air. And then looking at one of these individual impulses, you can get the area under the curve of that initial impulse. Then the force platform shakes a little, and knowing the mass of the ball, they can also get what the prediction is. They're introduced to the concept of the coefficient of restitution, the ratio of the speed of the ball just after a bounce to the speed just before the bounce. They derive an equation for it using the measured quantities from the lab. Using their equation, they predict the height of the 10th bounce and what bounce will result in half the initial height. The latter is more challenging, but it gives them a chance to finally use logarithms. It's a compelling experience for students to use the basic physics they've learned to accurately predict the seemingly arbitrary behavior of something like a bouncing ball. They'll never dribble a basketball again without thinking of physics. More information, including additional videos, can be found on the Wireless Force Platform product page at pasco.com. Student handouts and teacher guides for the bouncing ball investigation, a vertical jump activity, and more are in the Pasco Experiment Library. Thanks for watching.